Okay, so today we shall discuss about moving charges and magnetism. So in this moving charges and magnetism, first thing what we have to understand here is, for here this is a vector form here. Let us take one vector, another vector, and the angle between the two vectors is theta. So, and this is going to be force, okay, force due to magnetic field. So here this vector is taken as velocity, this vector is taken as magnetic field. If in this direction there is a velocity, in this direction there is a magnetic field, and what is said to be this one here, both the vectors are lying on the same plane. Let us imagine that these two vectors are lying on the, so V cross B, they are lying on the same plane. For example, this is V, this is B, and the force is acting perpendicular to both. So here V and B are on the plane. F is like, actually this is 3-dimensional figure. We can't draw 3-dimensional figure on 2-dimensional board, so we have to imagine. That means this force is perpendicular to B, this force is even perpendicular to V also. So this is an angle theta here. So we can use cross product to understand this. What is this? Cross product. Here, this is acting on the charge element. Okay, what's going to happen here? This force is acting on the charge. For example, I have taken one charge here. Let us take a negative charge. Okay, on this negative charge is having velocity in this direction and is having magnetic field in this direction. And if this charge is present here, on that charge, force is acting perpendicular to both B and V. That you have to understand here. Okay, so and let the charge of this charged particle is taken as Q here. So here, as this is going to be a vector product of vectors, now what we are going to do here, force due to magnetic field is Q into plus B. Okay, so force due to magnetic field is nothing but Q V B sin theta. So BVQ is just like some Hindi word, you know, BVQ and bhariya endukani will penchani. So BVQ, just like in Urdu. So remember, I am telling this word BVQ sin theta. Okay, so this is sin theta here. If angle theta is going to be 90 degrees, what is going to happen? Sin 90 is 1, isn't it? So what is going to happen here? Sin 90 is going to be 1 here. Therefore, we take this as, for example, instead of theta, there is 90 degrees. So force due to magnetic field is considered as BVQ. That's, isn't it? Is it okay? So now, this we will apply some practical example based on this. Let us see what's going to happen. So what I am going to do here is I am taking certain magnetic field. I am taking a magnetic field here. You know what is the meaning of this into? See, this into represents that North Pole is above the board, South Pole is behind the board. Understood? So, North Pole, South Pole. In the middle there is a board, let us imagine. And you know, magnetic lines of force enters from north to south always. So, you know there is a horseshoe magnet. And this horseshoe magnet is like this, okay? In which this is a North Pole, this is a South Pole. In between there is a board or a paper or a book, whatever it may be. So, now, here into represents that lines are passing perpendicular to the board, into the board, I-N-T-O, into. Here into symbol also that one same. Into means inside, perpendicular into the board. That is the meaning of into symbol, isn't it? If instead of into there are dots like this, dot is there. Into means inside the board, perpendicular to the board. Dot is there means outside the board, perpendicular to the board. That is the, let us imagine that I am going to consider one negatively charged particle, isn't it? I am taking one negatively charged particle here. Let us take one electron has entered in a magnetic field. So what is this into symbol representing? This is representing magnetic field. This electron enters with velocity v. Understood? Now, what are the things you are going to understand here? Will you give me some pen here? See here, this pen, green color pen, here green color into I am writing. It is into the board like this. Now, velocity is in this direction. Okay, both are lying on the same plane. Then what should be the direction of the force? Perpendicular to the both, isn't it? That means these two are perpendicular to each other like this. In this direction, force is acting in this direction. Understood? Okay. So now, what is going to happen here? See, force on the magnetic field is acting in this direction. Okay, in this direction. So whenever the electron enters into a magnetic field, what is going to happen? Force is acting on the electron. If this force does not allow the electron to go in a straight line, what does it do? It continuously drags it and makes this electron to move in a circular path. Understood? To move in a circular path. Okay. So this electron now starts moving in a circular path. Understood? So it's a perfect circle, and this perfect circle, then two forces are acting on this now. What are two forces? One is force due to magnetic field acting towards the center, and you know there is one more force acting away from the center, which is said to be centrifugal force. Understood? So centripetal force is the force due to magnetic field. Centrifugal force is the force which is acting away from the center always. Okay. So these two forces are counterbalancing each other. Okay. Now what is going to happen? Just see here now. See, force due to magnetic field is counterbalanced by centrifugal force. Okay. Just now I told you that force due to magnetic field is BQ sine 90. Okay. Because magnetic field and velocity, they are making 90 degrees. Okay. And what is going to happen? This is going to be mv square by r, which is acting away from the center. These two are counterbalancing each other. That's why it is moving in a perfect circle. See, if Fm dominates Fc, what happens? It will go in a spiral direction and it will stop at the middle. That's not going to happen. Okay. If Fc dominates, what happens? It go outward spiral and move away like this, tangentially. It is also not going to happen. As both are counterbalancing each other, they are having same magnitude, equal and in the opposite direction. So sin 90 is going to be 1 here. So it's going to happen BQ is equal to mv square by r. Okay. So v gets cancelled. Therefore r is nothing but mv by. So you all know mv is nothing but momentum, where momentum is a product of mass into velocity. Okay. So can we write this? So this is first thing is what you have to do is, this is the basic formula. Okay. This is the birth of one formula for radius of the orbit. For radius where the electron is going to revolve. Whenever it enters into a magnetic field. Okay. One electron enters into a magnetic field, magically unseen, unknown force is acting on the electron, which drives the electron to move in a perfect circle. Okay. Then what happens? Let's see. And that two electrons should perpendicularly enter to the magnetic field B, which is like this. Okay. So magnetic field around the electron exactly perpendicular move all. Then only to take perfect circle. Okay. So this is the first basic formula. Then after that, I have taken this as R is equal to P by BQ. So instead of P, what can you write now? You all know kinetic energy is nothing but half mv square. Now I will multiply m and divide with m. Then I will be getting now m square v square by 2m. Okay. So k is equal to m square v square is nothing but p square, because p is nothing but mv here, m square v square is nothing but p square. So I am taking p square. So from this I am getting p square is equal to 2mk. So can I take this as p square is nothing but 2mk. Or kinetic energy, sometimes it is also called as just energy we will consider. Instead of k we can take E also, energy. So we can write P is equal to root mk, or P can also be taken as 2me also, which is taking nothing but energy, kinetic energy only. Okay. Sometimes k means we take Boltzmann constant also. So to eliminate the confusion, we can take E as the energy, or k, sometimes whatever it may be. So anyhow, instead of P I can take root 2mk. So this is the birth of the second formula, where 2mk. Is it okay? So this is the second formula. Next we shall discuss about what is the third formula. Okay. We shall discuss about what is the third. See, kinetic and potential energy. Okay. Sometimes kinetic energy is also converted to potential energy. Energy can neither be created nor be destroyed, but it converts from one form to another form. Okay. So kinetic energy, which is nothing but half mv square. Potential energy, what is the formula? Potential energy is nothing but work done. So work done can also be considered as VQ, because potential here, potential is nothing but work done on unit charge. In electrostatics we have discussed about this. Our work done is nothing but VQ, right or not? VQ. So can I write this W as VQ now? Can I replace this kinetic energy with VQ? Energy or kinetic energy I can replace with VQ now. Is it? So instead of mk, I can also write it as VQ by VQ. Is it? Okay. So like this also we can write. So this is taken as the third formula. Understood? Okay. According to heat chapter, kinetic theory of gases in first year, we can also write kinetic energy is equal to half kT. Right? Kinetic theory of gases, so there is a formula called as half kT. So kinetic energy here. So that's why I told not to take k. We can take here. Energy can be taken as half kT. Kinetic energy of a gas molecule is taken as half kT, Boltzmann constant into absolute temperature. Okay. So what I am going to do now here, here I have taken energy as half kT, but here I have taken kinetic energy as VQ now. Instead of this kinetic energy, where we have already written, what did we write now previously? We have written here R is equal to square root of 2me. K or E both are square root of mkt by V. Like this also you can write radius. Okay. So these are some of the formulas here. Is it okay? Now, okay. So here, not only these formulas, you can play with this. Some more formulas we can. So what was the basic formula just now we have discussed? Is mv by bq. This is the basic formula number one. Next formula what we have written? We have taken this as p by bq. And this P by BQ can be taken as 2 ME or MK by BQ, or this can also be taken as 2 work BQ by BQ. This also we can take. Okay, this is the second formula. So if you take Boltzmann constant, what is it we are taking? MKT BQ. Like this also we can take. This is the third formula. Okay, these are the formulas which we have already discussed. Am I right? Just now we have covered all these three formulas. No? Further, how many formulas we can discuss? See, I just told you that whenever there is a circular motion, these many formulas will come. What is that circular motion? This electron moves in a circular path where force due to magnetic field and centrifugal forces are counterbalancing each other. And what is going to happen here? There is a magnetic field acting in this. Okay. So just now we discussed, we found about what is the radius, isn't it? So all these formulas are related to what? These are all related to radius. All formulas are related to radius. But we shall discuss some more formulas which are related to angular velocity, time period, frequency, and all these things. So how do we get angular velocity? Let me discuss here now. You all know V is equal to R omega, isn't it? Okay. So V is equal to R omega. So already we got some formulas here. V is equal to R omega, we can write, isn't it? So this is the basic formula. No? So can we write omega is equal to V by R? Yes. Already we got some formulas here. What is that formula? V you write like that only. But R means we got here mv by bq, is it? So can we cancel V and V? So what is the formula for omega? Q by m. What is the formula for angular velocity also? So this is the basic formula for angular velocity. This is the basic formula for angular velocity. First formula for angular velocity. Okay. So this is the first formula for radius. Second formula for radius. And this is going to be the third formula for radius. Is going to be the fourth formula for radius. Okay. This is one more formula here. Third. Let us imagine this will be fourth here. Okay. So angular velocity first formula we got. This is the first formula for angular velocity. So from this formula you can generate many formulas. You can generate time period. We can generate velocity. Frequency also we can generate. How? Let us discuss here. So this is angular velocity. You also know that omega can be written as 2 pi by capital T. Yes. So this can also be taken as bq by m, like that only. Instead of omega, I have taken 2 pi by t. You know, omega formula is 2 pi by t because omega is nothing but angular velocity by time. Because for complete revolution, theta will become 2 pi and time period will become capital T here. Alright or not? So I can take here the first formula. I got angular velocity. Now I will get the formula for time period. Okay. So I'm going to what I'm going to do here, just I will do reciprocal, isn't it? So here I will get T is equal to 2 pi m by b. So what the formula I am getting now? I am getting the formula for time period. First formula I got for angular velocity. Second formula I get for time period. I will get the third formula for even frequency also. What is the formula for frequency? You know frequency is nothing but reciprocal of time period, is it? So reciprocal of time period is nothing but reverse reciprocal. So I got so many formulas. Finally, I'll get one more formula. I can find out kinetic energy of the revolving particle. Any particle which is revolving, I got radius, I got angular velocity, I got frequency, I got time period. In the order I got about, and the confuses part. Now I am getting each and everything, just like we make one curry. What are the ingredients we are pouring in that, so that we can get the perfect curry. Direct formula check to that. Now I want to find out what is the kinetic energy of this revolving particle. How can I get the kinetic energy of this revolving particle? Same basic concept nunchi తీసుకొస్తాను kinetic energy. How we will get, let us see here. So just now we got R is equal to mv by dq. Okay. So all formulas are coming from this formula only. If you notice, all formulas are coming from this formula only. If you notice correctly. Okay. So therefore, what I am going to do now here, the next thing is, here I am taking V. I am taking V, which can be written as bqr by m. Alright. Just I am finding the velocity here. Now can I get kinetic energy from this? Kinetic energy is nothing but half m v square. So therefore kinetic energy is nothing but half m. V square means the same thing you write bqr by m whole square. So therefore kinetic energy is nothing but half m v square q square r square by m square. M square gets cancelled. Therefore you are getting a kinetic energy formula as v square q square r square by. So this kinetic energy formula, if you want, you can get from these formulas also. Here also getting kinetic energy, no? Where this energy, no? Yes. Already we got R is equal to root of 2me by bq. Getting or not? The magical thing is, from this formula also we can get. How? Let us see. So just remember, R is equal to root of 2me. R is equal to root of 2mk by bq. E and k na okate kada. Let us write k. So what I am going to get now? bqr is equal to 2mk root squaring on both sides b square q square r square is equal to 2m is one formula. Now, okay, so let me all the formulas we got from. So almost all the basic formulas are covered regarding the particle. Now we shall discuss where are you going to apply all these things. Now let us take here. Especially these applications are done on three particles. What is that particle? Tritium, and sometimes we take even instead of tritium we also take alpha particle. Okay. So proton, what is the meaning of this? Proton means the formula is H11. You know what this? Deuterium means we take H12. Alpha particle means it's nothing but helium, no? Helium 2 and 4, or it can also be taken as alpha particle plus. Let us have some simple logical formula. The same magnetic field I am taking. Can you spend some more time with me, or you want to go? No? 8 o'clock I will go and come in 10 minutes. Prayer is there. 8:10 I will come. 8:10 can I come take up to 9 today? Any problem is there? Nothing. You can follow. I will do the phone also. I will. Okay, still I have got 5 more minutes to explain it. Now just here. See, in this magnetic field B, what happens if alpha particle enters, deuterium enters, proton enters? What is the ratio of their radii? Understood? For example, first let us imagine what is entering. H1 is entering. Okay. And next what is going to enter? H12 is entering. Let us take alpha plus 2 and 4. It is also going to enter. So this is the radius of proton. This is the radius of deuterium, Rd. This is the radius of alpha particle, R alpha. See, proton I am taking Rp, deuterium I am taking Rd, and this is R alpha. What happens to their radius if they enter into the same magnetic field with same velocity? Their velocity is also same. Then what happens? Same velocity. Then what is our formula actually? You know R is equal to mv by dq. Okay. So here according to our question, here they are entering with the condition is same velocity, same magnetic field d. Okay. Then what is happening here? Radius is directly proportional to m by q. Radius of proton is to radius of deuterium is to radius of alpha particle is equal to m proton by q proton is to m deuterium by q deuterium. Mass of proton is 1, isn't it? Charge of proton is 1. Is to mass of deuterium is 2. And charge of deuterium is 1. Is to mass of alpha is 4. And charge of alpha is 2. So 2 ones, 2 twos. So it is 1 is 2 is the ratio for radius of the proton, radius of the deuterium, and radius of the alpha particle. 1 is to 2. Just remember this ratio. 1 is to 2. Okay. This is the first type of problem I am doing. Okay. This is a model number 1. Now let me go for the next problem. What is the next problem here? In this magnetic field, okay, in this magnetic field, 3 things are entering. What is that? One is proton is entering, another is deuterium is entering, another is alpha particles also entering, and they are entering with same momentum P. Okay. So what is going to happen? First thing is proton, deuterium, and alpha particle. Condition is same momentum and same magnetic field. Then what is the ratio of their radii? So whatever he has given, the formula should be in that form only. What is that formula? We have to consider. Can you guess? Now we have to consider the formula as P by dq. Alright? Why? Because he has given momentum P, same P another, same B another. Okay? Na? So P, B, rendu formula this formula. In the mundu V and B another. V, B this formula. So here he has given momentum and field. So these things should be taken, cancelled. These things should be removed. Okay. So R is inversely proportional to Q. So radius of radius of deuterium, radius of alpha particle is equal to 1 by Q of proton, 1 by Q of deuterium, 1 by Q of alpha is nothing but charge on proton is how much? See, proton means H1, deuterium means H12, alpha means plus 2 and 4, mass is plus 4 and charge is plus 2. So 1 by Q proton is 1:1, 1 by Q deuterium is 1:1 only. And 1 of alpha particle is how much? 1:2. Okay. So denominator lo vachindi kada. A denominator ni numerator lo vachetట్లా చూసుకోవాలి. అంటే ఏం చేయాలా? అన్ని చోట్ల 2 తో మల్టిప్లై చేయాలి ఇక్కడ. అప్పుడు ఏమొస్తది? 2 క్యాన్సిల్ 2:2:1 అవుతుంది రేషియో. అర్థమైనది? సి రేషియో మాట్లాడినప్పుడు డినామినేటర్ లో ఏది ఉండకూడదు. న్యూమరేటర్ లో వచ్చేటట్టు చూసుకోవాలి. ఎలా వస్తుంది అంటే రేషియో కాబట్టి అన్నిట్లో మల్టిప్లై. ఇఫ్ యూ మల్టిప్లై విత్ 2 you will get the same ratio. Now, okay, this is the second model of problem. Same B, first condition. And same kinetic energy now, same K. Okay, so in this, what are the things happening? Proton is entering. Okay, what is going to happen? Deuterium is also entering, and alpha particles also entering in the same magnetic field with the same kinetic energy. then we have to consider the formula in which kinetic energy is present and what else is present? Magnetic field is present. So what is that formula? R is equal to square root of 2 mk by dq. Okay, so we have to consider the constants and remove them. B can be removed. Now 2 is also constant. R is directly proportional to root m by q now is equal to root m of proton by q of proton, root m of deuterium by q of deuterium, root m of alpha by q of alpha. Then what I am going to get now? M of proton is 1. This is 1. And m of deuterium is 2. Root 2 by 1. Here this is root 4 by root 4 and 2 na? Cancel, you get 1 only. So your answer is root 1 is to root 2 is to root 1 is nothing but 1 only, no? Okay. So today the next topic of this moving charges and magnetism, that is Biot-Savart law and its applications. We shall discuss about that. Okay. Did I explain about Biot-Savart law? So see, for example, you are considering a wire. In this wire, current I is passing. Okay. So whenever the current is passing through a wire, you should know that surrounding the wire magnetic field induction is developed. So it creates a magnetic field of attraction towards the wire whenever the current passes through the wire. Okay, and that magnetic field, how much it will be because of a small part of a wire. For example, I am considering only this much part of a wire, dl, small part, whereas the total length, net length is L. From top to bottom, the total length of the wire is L. In that, I am considering the smallest part of the wire, which is taken as dl, differentiated part of the length, means chinna small part. Okay, so because of this part, what is the magnetic induction at this particular point? So we can consider dB. Okay, so small amount of magnetic induction is dB, small amount of length is dl. Is it? Okay, so dB and dl. Okay, so total length is L, total magnetic induction is d. Small part of the length is dl and small part of the magnetic induction is d. How much will be this dB? And here, let us imagine this is radius. The distance from here to here is r, and the angle which is taken as theta here. Okay, so the angle is taken as theta. Now, so this is said to be Biot-Savart law. The two scientists has described this law, Biot-Savart law, magnetic induction. Whenever the current passes through the wire, surrounding the wire magnetic field is developed, and that magnetic field, dB, because of small part dl, is going to be directly proportional to current passing through the wire. For example, current I is passing. More current passes, more magnetic induction is developed. Less current passes, less magnetic induction is developed. Okay, and dB is directly proportional to dl. Greater the length, greater the magnetic induction. Lesser the length, lesser the magnetic induction. And dB is directly proportional to sin theta. The greater the angle, the greater the magnetic induction. And maximum value will be for 90 because sin 90 is 1, which is maximum. Sin 30, 1 by 2. So sin 30, 1 by 2. Sin 60, root 3 by 2. Sin 90, 1. Understood? Is it clear? Yes. Okay. So sin theta, sin 90. Let us imagine these are all. And dB is inversely proportional to r square. The greater the length, the lesser the magnetic induction. The greater the length, the lesser the magnetic induction. Is it clear? So, distance, how much it increases, it becomes lesser. Magnetic influence will be less. The magnetic field developed because of this wire decreases as you move away. It decreases, it becomes lesser. So, now, if you join all these, then what are you going to get now? You are getting dB is directly proportional to I dl sin theta divided by r square. When you remove this proportionality, you will get a constant. What is that constant? Mu naught by 4 pi I dl sin theta divided by. Okay, so what is an application here? For example, you are going to consider an infinitely long wire. Okay, no. Okay, so this is an infinitely long wire. For example, here at particular distance from here to here, because of this wire, the smallest part of a wire you consider. Let us take this is dl. And let us imagine at this place if you consider, okay, so how much you are going to take this angle? Let us imagine this is phi and this is theta, okay, and the magnetic induction developed here is taken as dB because of smallest part. Previously we have taken a general case where you are taking a curved wire, but now you are taking a straight wire, and that too unlimited length wire. Okay, this wire is having unlimited length. Here infinity going like that only. Here also infinity going like that only. Infinitely long wire I am taking. Okay, Now let us take here from here to here. If you consider, let this angle is phi 1. From here to here, if you open phi 2, this is phi. This is theta. And what is this going to be? This is 90 degrees. Is it? Understood? Okay. So from DL, let us consider the length is R and this is D. Let us imagine. Or you can take this as a D and this as R. Understood? So now what is going to happen? What is Biot-Savart law? Okay. So Biot-Savart law, BSL, says that dB is equal to mu naught by 4 pi I dl sin theta divided by r square. Is it? R means the distance here. But now I have taken distance as d. Now I have taken distance as d. So you can consider here instead of r square you can take it as d square. The distance d square this one. Okay. So now like that you have considered. Here let us take what is the meaning of this. What are we going to get now? Dl means what? Let us see. Now if you consider here tan phi this one. Tan phi means what? Here let us take from here to here the length is L. From here to here the length is L. So tan phi is nothing but opposite side. So this is taken as R is equal, L is equal to R tan phi. So if you differentiate, dl is equal to R tan phi. Differentiation of tan phi is nothing but secant square phi. Understood? And again if you differentiate phi, you get d phi. Is it clear? So secant square phi d phi. Understood? Now what are you going to take here? You can consider sin phi. Or else you take secant phi again. Secant phi means what? See, cos means adjacent side by hypotenuse. Secant means hypotenuse by adjacent side. Cos ki inverse anamata secant. Cos at adjacent by hypotenuse. Secant at hypotenuse by reverse. Okay. So what is d now? D is going to be r secant phi. Understood? So what are the values we are getting now? We got a dl value. We got a d value. Okay. So I got a d value, I got dl value. Now I have to find out what is sin theta. You can just see here, for example, you know here, this is 90 means theta plus phi is equal to 90 because it is 90 and I got the value of even sin theta which is equal to cos phi. Okay, so now I got all the values you can substitute here. You will get a new formula. What I am getting now? So all the values you substitute here. Okay, now see in the place of dB, now you write I mu naught by 4 pi and I you write like that only. dl means what you write? Secant square phi. Again sin theta means you write cos phi. Divided by what is left now? D square is left now. There. So d square means you take this value. R square secant square phi. Is it? So what are the things getting cancelled here? Just secant square phi. R square gets cancelled. Is it? So now at last what is left now? dB is equal to mu naught I by 4 pi r cos phi d phi. Okay? Is it okay? Now I want B. B I want means I have to integrate. From where to where I have to integrate? Phi 1 downwards, phi 2 upwards. This is phi 1. That is phi 2. So limits are from minus phi 1 to plus phi 2. Why minus phi 1? If you observe, if you imagine this to be origin, downward it is minus phi 1, upward it is plus phi 2. Okay. So these are the limits now. So here, these are all constants. You can apply integration only for this much part, isn't it? These are all constants. So what I am going to get now? B is equal to mu naught I by 4 pi r integration of cos phi d phi. Cos phi means minus sin phi. Limits are from minus phi 1 to plus phi 2. So therefore, finally what are we going to get now? We are getting B is equal to mu naught I by 4 pi r. You apply this minus outside sin phi 2 plus sin minus phi. Is it? Yeah. So minus was here we get minus. This is plus only. See here, cos phi is going to be integration of cos phi is sin phi only. Integration of sin phi is minus cos phi. So here we will not get any minus. Here we will not get any minus. So this minus of minus will become plus. So finally, what is the formula getting? So B is equal to mu naught I by 4 pi r integration of sin phi 2 plus sin phi 2. Is it okay? So this is the first application of Biot-Savart law for infinitely long wire. So now here, if it is infinitely long wire, what happens? So I have taken from starting point as this one and ending point as this one. But if you consider infinitely long wire, what happens? This phi 1, if it is infinitely long wire, this phi 1 will open and becomes infinity. Is it? Phi 1 will expand now? Will extend and becomes infinity means this will open and become 90 degrees. That also going infinity means it is opening like this. Infinitely long wire means becomes 90. So phi 1 and phi 2 will become 90 if it is infinitely long wire. Understood? So this is the general formula. No. So what is the formula getting? Mu naught I by, this is going to be B. For infinitely long wire, phi 1 is equal to phi 2 is equal to 90 degrees. Okay. So for infinitely long wire, mu naught I by 4 pi r, which is nothing but sine 90 plus sine 90. Is going to be 1 plus 1, 2, 2. Okay. This is 1, no? This is 2. So 2 ones, 2 2s. So B for infinitely long wire is going to be mu naught I by. Is it okay? Infinitely long wire formula got. Now let us take one small application for this. Now I have taken a square of side A. I have to and the current passing through this is I. At the middle, at the center, I want to find out what is the magnetic induction developed because of this square. How will you find out? You will draw one line like this. You draw one line like this. And you will draw this distance R. What is this R? This distance R is considered as A by 2. Because total length is A. From the middle to this side, A by 2. R is A by 2. Now what is this angle? And this angle for a square, this is 45 degrees and this is 45 degrees. Those two angles are 45 degrees. Understood? Is it clear? Now we are applying the same Biot-Savart application what we got just now. So this formula, we have to use this formula. What is this formula? Okay. Mu naught I by 4 pi r sin phi 1 plus sin phi 2. Is it? So B is equal to mu naught I by 4 pi r sin phi 1 means sin 40. This is only the application of Biot-Savart. No? 5 plus to 45, 40. Phi 2 is 45 in this application. 45 plus 45. Is it okay? Now what is R? R is equal to A by 2. Understood? So instead of R, what will you write? A by 2. 2 ones, 2 twos. So B is equal to mu naught I by 2 pi A sin 45 is 1 by root 2 plus, so B is equal to mu naught I by 2 pi A into 2 by root. So these two gets cancelled. B is equal to mu naught I by root 2 pi A. Understood? So what is this? This is for one side. For total 4 sides, B net going to become how much? B net is going to become 4 times of B because 4 sides are extra. So therefore B net is going to 2 root 2 mu naught I by pi A is the answer. Okay. Now the same Biot-Savart I apply in a triangle. Okay. So this is a triangle, equilateral triangle taking 60 degrees. Is A. Understood? Side is A. Then what is this distance? This is actually R, no? We have to find out this distance. How will you find out this distance? See, totally 60 means this is 30. This is half part, no? A by 2. Now I want R. So can I take this as tan 30 means? Tan 30 means opposite side R by adjacent side A by 2. So R is equal to A by 2 tan 30. So therefore R is equal to A by 2 tan 30 means 1 by root 3. So R is nothing but A by root 3. So this is 30. This is 90. Means is it not 60? This is also 60. Understood? Now we apply the same law. Biot-Savart law, mu naught I by 4 pi r sin 60 plus sin 60. Is it okay? So B is equal to mu naught I. Instead of R, I am writing A by 2 root 3. So sin 60 is nothing but root 3 by 2 plus root 3 by 2. That? Okay. 4 pi is also there. Instead of R, I am writing like this. So if you simplify, what are you going to get now? Finally, B is equal to mu naught I by 4 pi A. There are 2 ones, 2 twos. So here also 2 pi A. So root 3 will go to the numerator. And this is root 3 by 2 plus root 3 by 2 means 2 root 3 by 2. 1 plus 1, 2 na? 2 root 3 by 2. Here root 3 into root 3 is 3. So therefore, B is going to be how much? 3 mu naught I by 2 pi A. This is for one side now. For 3 sides, if you want, what is now doing? So therefore, B net is nothing but 4B. So 3B. For 3 sides, 3B will take. Understood? So what I am going to get now? B net is going to be 3 3s are 9 mu naught I by 2 pi A. This is your final solution for a equilateral triangle. Square is over. Equilateral triangle is over. Okay. Now see here. The same Biot-Savart law I am applying for a circle. If you take a circle, what happens? So this is the center of a circle. I am taking this much part of the circle whose length is dl Let us imagine this distance is r. Okay. So because of this dl, the magnetic induction developed is dB. Understood? Here angle will be exactly 90 degrees. Means theta will be 90 degrees with this part of a circle. Okay. Now what is Biot-Savart law? dB is equal to mu naught by 4 pi I. What I am going to get now? I dl sin 90 divided by r. Is it? Okay. So sin 90, because theta is going to be 90 degrees. This circle. See, if you draw a radius, it exactly makes 90 degrees with the arc of a circle. Wherever you draw a radius, it makes 90 degrees. That is geometry, r square. Okay. So sin 90 means what? You need not write 1 now. As it is 1, you did not write here. So next what is going to happen? So therefore dB is equal to mu naught I by dl by 4 pi r square. If you want to find out b, you have to integrate dB. Understood? Is it okay? So here, as you want to integrate here, what will you do? Only dl you have to integrate. Only dl you have to. So if you integrate dl, you will get total length, no? So what is integration of dl? It is nothing but 2 pi r. Circumference of a circle. Circle is chinna part is integration is 2 pi r also. Total circle is 2 pi r. So you will be getting b is equal to mu naught I by 4 pi r square into 2 pi r. So r square gets cancelled, pi gets cancelled 2 ones. Therefore b is equal to mu. Okay. So this is for a complete circle. This is for a complete circle. Understood? Okay. Now, if it is the case here, then what happens if it is 1/4 of a circle? What happens for half of a circle? This is for a complete circle, no? Mu naught I by 2r is for a complete circle. Okay. Now, let me take what happens if you take only half circle. Is it? Half circle. For complete circle, what is the formula? Mu naught I by 2r. Okay. This is for complete circle. If you take only 1/4 of a circle, only this much part of a circle you take. 90 degrees, no? Only 1/4 of a at the center because of current passing through the 1/4 of a circle. Then what is the formula? 1 by 4 times of mu naught I by 2r. Therefore, v 1 by 4 is nothing but mu naught I by 8r. Is it okay? Mu naught I by 8r is the formula. Now, for example, you are taking in a complete circle. Now, this is 3 by 4th of a circle. At this point, you have to find out dB when the current passing through the circuit is I. Understood? Is it clear? So what is your formula now? B for a complete circle is how much? Mu naught I by 2r. B for 3/4 of a circle is 3 by 4 times of mu naught I by 2r. So therefore, finally, B because of 3 by 4 is nothing but by 8r. Is it clear? Okay. So current is passing like this and is coming out like this. Okay. So how will you get now? This is the first part, 3/4 of a circle is the second part, and this is up to here it is a 3/4 of a circle, and this is going to be third part. See, because of first part, D will become 0. Why? Because it is exactly, this line is exactly opposite to the center. So if you extend, it has to pass through the center. So magnetic induction, because of the line on the circle, on the wire is going to be 0. At certain distance you will get B. Why it is 0? There is no magnetic induction very close to the wire. On the wire there is magnetic induction. No magnetic induction. Like that only, exactly opposite. If any line is, any wire is passing, magnetic induction is going to be 0. Understood? Clear? At this place, for this wire there is no magnetic induction. It is 3/4 of mu naught I by 2r. So therefore B2 is equal to 3 mu naught I by 8r. And for the remaining part, this is not infinitely, completely long wire. Infinitely long wire means here also infinity should be, no? So for infinitely long wire, what was the formula? Mu naught I by 2 pi r, no? So what was the formula? Here. For infinitely long wire, mu naught I by 2 pi r we have discussed it. Understood? But this is not an infinitely long wire. Okay? Only this is 50% infinitely long wire. Means half of infinitely long wire. ఇక్కడ నుంచి ఇన్ఫినిటీ లేదు, ఇది ఇక్కడ నుంచి ఇన్ఫినిటీ ఉంది, ఇక్కడ నుంచి వైరే లేదు అక్కడ ఇన్ఫినిటీ 50%. So what is the answer? B3, third part. This is the third part. So what is B3 now? B3 is equal to mu naught I by 4 pi r. Okay? So B1 is 0, B2 is this much, B3 is this much. So totally how much it is going to be? B net is going to become B1 plus B2 plus B3. Only B2 plus B3. So you just add. What is that you are going to add now? 3 mu naught I by 8r plus mu naught I by 4 pi r. Understood? Like this you have to add them. If you want, you can just simplify also. Then we'll say mu naught I by 4 th. If you want, you can just common out mu naught I by 4r, and you can just write it. But whether here you just see current is passing in this way, no? Clockwise direction. Ampere's right hand rule you have to use. For example, 4 fingers you will take, they are in this direction. Thumb is inside, no? Thumb inside means into the board. So here you have to write the value for this B2, no? B2 is into means magnetic induction will be into the board and rule. 4 fingers here because of this wire, where is the magnetic induction? Here you take the thumb like this and 4 fingers will be magnetic induction. So like this thumb, 4 fingers inside. Okay. So here this is also into. So both intos will become again into only. You have to add them, that's it. Is it clear? Okay. So next, for example, like this. Here infinity, here also infinity. At this place he is asking us to find out magnetic induction B. Okay. So 3 things you have to observe here also. This is wire 1, this is wire 2, and this is wire 3. Now let us imagine current is passing like this in all the 3 wires. Okay. This is half infinite wire. For full infinite wire, I told you the formula is mu naught I by 2 pi r. Infinitely long wire. But here there is no wire, but this side it is infinitely long wire, means just half of that one will become how much? Mu naught I by 4 pi r. 2 pi r divided by 2 will become 4 pi r. So this is V1, which is all B net is going to become V1 plus V2. So here, this is the thumb along the direction of current. 4 fingers, it will go and enter like this. Then global key into. So B2 and B3 are into. Here also it is going like this thumb. 4 fingers like this. That means the 4 fingers will go into. Both are into only. B1 and B2 are into. Now this is like this, no? For curve, 4 fingers will be curve, thumb will be B. Here also into only, no? Like this, into. Means all the 3 are intos only, into the board. So just you have to add them. B net is equal to B1 how much? Mu naught I by 4 pi r. B1 plus B2 means same 2 times, no? Multiply by 2. So 2 ones. So directly generate mu naught I by 2 pi r. Okay. Here half wire full. Here half infinite wire. Here half infinite. Means both combined together full infinite wire. Because how much? Mu naught I by pi r plus that one. Mu naught I by 4r into. If you want to just simplify, mu naught I by 2, 1 by plus 1 by 2 r also. Simplification you can do. Okay. So next, one more model. For example, infinitely long wire. At this point you have to find out B. So this is 1/4 of a wire. The current is coming like this. It is entering. It is moving outside like this. What is the answer for this? It is exactly opposite to this dot. Because of this 0 only, this is the considered. So therefore, B net is going to become. It is 1/4 of a full wire. So therefore, B net is going to become how much? 1/4 of B full means mu naught I by 2r. Full circle, mu naught I by 2r. 1. So therefore, B net is going to become mu naught I by 8r. So 4 fingers along the direction of the current into. Understood? Okay. So now, one wire is like this. This is infinity, this is also infinity. Understood? Here this is current, here current. So this is 1, this is 2, this is 3. Okay. This is the half circle. It is exactly opposite to this dot. Because of B2, is it not a half circle? So half full circle means mu naught I by 2r, half. So therefore B2 is how much? Mu naught I by 4r. Okay. So B3 means half infinite circle. So half of full infinite circle. Mu naught I by 2 pi r is half. So how much will become? This is equal to mu naught I by 4 pi r. Is it okay? So therefore B net is equal to B1 plus B2. Mu naught I by 4r plus mu naught I by 4 pi r. Okay, so start. I will post in the video remaining.